Hola, SAP developers. Welcome to this session, part of the ToolFest 2023 integration track. Before we start, I just want to let you know to please feel free to drop us your questions on the chat window, as we'll be monitoring it, and we will answer your questions there. This session will be all about custom scripts in cloud integration. Today, we have Vadim, who is an independent SAP integration architect. He will tell us about tools and techniques that you can use while developing custom scripts in SAP Cloud Integration. Without any further delay, hola, Vadim, over to you.
Hi, everybody. Hi, Antonio. Thank you for hosting me here. And I'm very pleased that I can run this session and describe my experience with some tools and some techniques that hopefully will be helpful to other integration developers. So this session is partly about developer productivity tools and partly about code quality tools, and those of them which can be applied to development of custom scripts in the SAP Cloud Integration. And although the techniques that I will describe, they are quite agnostic from languages and from frameworks, I will primarily focus on tools that are applicable to Groovy scripts development. As we know, we can develop scripts in JavaScript and in Groovy, but it feels like Groovy is a more popular choice for custom scripts development. So the tooling section of this presentation will revolve around Groovy or Groovy compatible tools. When we speak about developer productivity and code quality, although techniques and tools are quite different, these are quite different areas, I would like to start with the emphasis that they play hand in hand. So we have developer productivity tools that help the developer work better and have the better toolbox to compose higher quality scripts. But we also have a code quality assurance tools that run formal checks and some scripts to validate certain aspects of the script, or to place it at runtime and test it at runtime. So quite commonly, we will see that these two areas, they coexist very nicely and they interact with each other. So we will see that actually the developer workflow, although it's kind of developer productivity, but it's highly impacted and it's infused with code quality assurance tools. So we will start with developer productivity first, and here I would like to start with quite fundamental basis of the tooling, which is not immediately the editor where we develop and where we compose scripts, but those subsystems which are responsible for managing the underlying aspects of the development. The first of them is version control. Although the scripts, custom scripts, they can be quite lightweight, so not necessarily they go to very high complexity level. Still, it's very critical that we version control such developments. And we have to have capability to trace the implemented changes so that we can travel back and forth. So it's very common that we develop a script, we implement some mapping requirement or some other integration requirement. And then this requirement changes over time. Sometimes it evolves, but sometimes we need to roll back to something that has been developed and overwritten in the past, from the past. And this is where we shall have this possibility to roll back to some past versions of the code, or to apply to cherry pick some aspects of the developed functionality from other branches or commits. And these changes have to be very atomic. So sometimes it could be on the field level mapping, or sometimes even on the function that implements a certain aspect of the mapping or another part of the integration requirement. And last but not least, the tool shall allow us branching and merging so that some scripts can go very complex. And it's very common that for those scripts, we would like to introduce a more controlled way how we implement and track changes. So a lot of those, if not all bullet points that we described here, quite commonly lead us to Git-based systems. So I will not speak about the particular tools right now. So now I will speak more about techniques. At the end of the presentation, we will have a consolidated table of some tools that are convenient and that are applicable for Groovy development, but version control significantly and heavily revolves around Git-based systems. The second one is dependency management, the right section. Although custom scripts, regular custom scripts in cloud integration, in SAP Cloud Integration, they don't have a lot of dependencies, and those dependencies which are commonly used are those related to XML, to JSON processing, to the message objects themselves. Still, there are some use cases where we have to go one step forward and plug in some third-party dependencies. So those could be libraries to facilitate certain aspects of the mapping composition, or sometimes we need security requirements. For example, we need to implement very specific encryption algorithm, and we already have a library that can be used for that, and which is approved for the usage by the organization. So for complex scripts, the dependency management becomes quite a cornerstone. And this is where we have to traverse not only the direct first-level dependencies that we literally inject and add into our project and import in our script, but also transitive dependencies. Because commonly for libraries, we can see that those libraries use some other dependencies under the hood and so on and so on. So it can be composed as a tree structure. And when we manage the dependency, we shall not forget about transitive dependencies as well. So we literally shall be aware about the entire tree of dependencies that get used by the script, not only the high-level dependencies that we imported. And the ideal way to visualize it is to present it as a graph. Plus, in sake of performance, the tooling shall be able to cache dependencies so that we don't need to fetch them every time. And it shall support multi-repository, which means that some dependencies, some libraries, we may fetch from different repositories. For example, we can use Maven, we can use something from the corporate repositories, or there may be some other libraries which I published elsewhere by library authors, and we would like to fetch them. So the way from the destination from where we fetch those dependencies, it shall be quite transparent for the developer. So this version control and dependency management, these are kind of basis for the future development, and then we go level up. And this is where the integration developer spends the most time when developing scripts, either code editor or integrated development environment. Why I put them on the same line is because in the past, code editors were like simple text/code editing capabilities. But now when we look into modern code editors, they can be enhanced with a lot of different extensions and plugins. So a lot of functionalities which were in the past natural to IDE and were not present in the code editor now can live in the code editor. That's why both are relevant in our case. For the code editor IDE, the important part is code completion and code templates. So a lot of skeletons that we develop for scripts, they can be templated, and we can automate the generation of the boilerplate. Like, for example, function definition, some return statements, some aspects of parsing of the JSON document or XML document that we retrieve from the message payload, and so on. Code refactoring, it's another common and quite critical aspect when scripts become more complex. So it's common that we start script development from something basic, and then the complexity goes up. And we find ourselves in the situation where we need to refactor the existing code, for example, to create some functions, to make different decisions about modularization of the code. And this is where code refactoring is really critical. And the code editor shall allow us to be extensible and to integrate into the overall development infrastructure. As I mentioned, the extensibility bit, availability of extensions and plugins for different code editors, it's something which really improves our work and helps us to produce the high quality code quicker. We also have a built-in web-based script editor. We shall not forget about that one, which is already available within the SAP Cloud Integration UI. But that editor is commonly useful for basic scripts development because it lacks some capabilities that standalone code editors and IDEs can present to us. So if we need to create a quick, rapid script, quite short script, we can do it nicely in the embedded script editor. For anything more advanced, and for something where we need to have like controls of versions and so on and so on, this code editor is not applicable much, and this is where we get back to standalone IDEs and code editors. On top of code editors, and now it's quite popular to have different assistants, which are commonly AI-powered assistants, and Groovy development is not the exception in here. So quite a lot of coding assistants, they are wrapped into extensions, into plugins for a variety of popular code editors and IDEs, so we can install them and make use of them, specifically for a rapid generation of the code that is not static. So for static code, we have code templates, which are a common feature for modern IDEs and code editors. But with AI-powered coding assistants, we can generate some dynamic code snippets. What is also very powerful and very useful in integration scripts development is the way how the AI assistant can generate the code snippets. So we can use natural language comments. So we can define in the comment of what we would like the code snippet to do, and the AI assistant will generate the code snippet for us, and also code fragments. So we can start typing the code. For example, we can start typing that we would like to parse the message body or to extract some value from the XML payload, and the code assistant will propose the entire code snippet based on the beginning of code that we type. So these two capabilities, they are quite critical and they are quite useful in my personal view. They significantly boost the performance of the developer in SAP Cloud Integration. What is critical here is that we would like to make this code assistant respect the style and the existing code base. And this is where general purpose assistants, like, for example, ChatGPT, are not very convenient and very efficient. Don't take me wrong, I don't have anything against ChatGPT, and it's a very powerful tool. But when it comes to the development or improvement of the code in particular scripts, we need something in our toolbox which is more fine-tuned to our project. That's why the coding assistants that I will mention in the later section, those are convenient, useful in the way that they can analyze the existing code base of the project, and they try to generate and to propose the code snippets that are coherent with that code base, which means that, for example, the styling of the code will be coherent with what has been already developed in the project. The problem of the coding, or limitation of the coding assistants, is that a lot of existing coding assistants, they work really well with Java and with some other languages, but Groovy is more niche language, and a lot of those popular assistants which are used in Java, they don't perform well with the Groovy code, in sense that they happen to produce the code which is more Java-like code and which is not Groovy-nized code. So the accuracy and quality of generated code suggestions can be lower. And after we spoke about developer productivity, tools that can improve and help the developer develop the code better and quicker, we switch to the other part. We will speak about code quality assurance tools that can be used by the developer or by the testing team. And a lot of these tools, they also can be integrated into IDE or into the pipeline, the development pipeline. For example, if there is some CI/CD platform. Here, I split it into 4 sections, and you will see 2 colors. We will speak about them. The first group of code quality assurance tools is static code analysis. So these are tools that analyze the code of the script or of the project, and they try to help detect the code weaknesses as early as possible. And here we speak about some weaknesses that can be security related, and also some flows that are styling related, and some misuse of common best practices for the coding. And here the tools can also help verify compliance to the development guidelines. For example, naming conventions and so on. Static code analysis, it doesn't require the code to get executed. So it literally statically scans the code base. The other group of tools is dynamic code analysis. This is where we have to execute the script under test, to put it at runtime, and to analyze how the script behaves at runtime. From here, we can pick up extra checks and we can validate the script against checks which are not discoverable purely looking into the code of the script. For example, we can provide some input for the script and see how it behaves under certain corner cases or edge cases, or at least how it behaves on the common cases. The next section is dependency analysis. As I mentioned, it's not something that can be widely used for simple cases, but for more complex scripts, it becomes very handy. We shall not forget that although we focus on the development of our script, if we have any dependencies, especially if those dependencies are quite niche, or a lot of dependencies have been introduced to the project, or we need to analyze those dependencies as well. And here I'm speaking not only about technical analysis, but also about some non-technical aspects, because we literally take somebody else's code and use in our script. So I will speak about it, that it's not only technical checks that we have to perform here. And performance analysis. In performance analysis, especially it's relevant for scripts that will be embedded into integration flows that run under high volume constraints. We shall have the capability to inspect resources consumption of the script and to see where we have potential bottlenecks and if those can be optimized. For example, as a developer, if it can be optimized through the code optimization, or maybe we have to highlight that there are some possible bottlenecks that will be caused by the script put in the particular runtime. And the other part of the performance analysis is benchmarking. So benchmarking, we will speak about it. It will provide us more accurate, statistically accurate information about the performance of the script execution. You will see that we have blue color and green color. Blue-colored approaches, they don't require script execution. So they operate on the analysis of the code base or analysis of the dependencies which have been added to the project. Those which are colored in green, they do require execution of the script at runtime. And we will speak about constraints which reduce the accuracy of execution of those checks on the slide after this one. So I will start with static analysis. Just bear in mind that on the previous slide, there was a section called static code analysis. This section covers the entirety of static analysis, where the code analysis of the code is just one part of it. So we have static code analysis that is to detect early weaknesses. So this is where we have certain checks. For Java and for Groovy, there are quite a lot of pre-built checks in tools that I will speak about. We can also create custom checks. So for example, certain checks of return parameters, certain checks how switch if statements are composed, validation of input parameters, and so on and so on. We also have the tools that are specifically focused on static application security testing. So those tools, they look into the code from perspective of possible security flows. So for example, where we can expect some overflow, or we can expect in injection attacks, like for example, XML injection or JSON injection or SQL injection, or so on. And on this level, we can also enforce the compliance with the style guides that I mentioned. As well as with version control, it's a very great feature for modern static code analysis tools that we can analyze how our scripts, how our code improved over the time, or sometimes degraded over the time. This is done by capturing the snapshots or results of runs, and then historic analysis between those runs retrospectively. This can help us to see if the improvement of the script in one aspect at least didn't degrade the script in the other aspect. So for example, we could fix the problem with security, but we could introduce, as a consequence of that, some other problem with the naming or with styling of the script. The other part is software composition analysis. So this is the analysis of third-party open source dependencies. So this is our dependency analysis bit of the static analysis. We don't require to execute the script. What these tools commonly do is they analyze the dependencies that were defined for the project. And this is where tools like Gradle and Maven, which are originally Java build configuration tools, become handy. So when we use these tools, we define the script the dependencies that we intend to use in the project, and then the software composition analysis tools, they scan these dependencies, they compose the tree of those dependencies. They expand dependencies so that we can see what transitive dependencies were used. And also it can analyze if there are any known security flows in dependencies which will become added into the project. This is technical part. We also have non-technical. When we add any third-party dependency, we shall not forget about the licensing aspect. And this licensing aspect is very critical, especially when it comes to the commercial development for cloud integration or for any other sort of development. So if we use, it's not only to find the library which can help us solve some problem quicker or which implements some algorithm, it's also to evaluate if the licensing model of that library is compatible to our development and the intention how we plan to roll out this development. So software composition analysis tools commonly will also be able to highlight what licenses are used, especially if those licenses are very restrictive. So it's not a big issue when it's permissive license, but when licenses are very restrictive, they alone can become a pitfall in the usage of the library, even if it is a nice fit from technical perspective. And after static analysis, we come to the dynamic analysis tools. This is where we have more sections. Firstly, we have unit testing, which is quite traditional for software development and which we shall also leverage in as a best practice in the development of scripts in SAP Cloud Integration. The main objective of unit testing is to validate that changes that we introduce to the script allow the script to behave as expected. So for example, we have certain inputs that we feed into the script, we implemented logic or we changed the logic of the script, and we have some expected outputs of the script. For example, if it's a script used in the mapping, then we can feed into inputs of the payloads and see how to which outputs the script will lead us to. And then we can validate if outputs correspond to what we expect. We also have to use this as a tool for regression testing, because whenever we introduce some change, we not need to forget that we need to ensure that we didn't break anything from the past, that something that worked in the past. This is where we have regression testing as well. And the preference here is to use declarative definition of unit tests. We will speak about the tool that can help us to do so. Firstly, it's more convenient that we can define it, especially it's convenient for test-driven development approach, where we define script tests upfront, and then we declare what we would like to expect from the script or from the function. Then it's easier for us to map the output to the expected output to the reality. And also, same way as for static code analysis, it's a nice feature to have historic analysis, so that any unit test runs that we execute to test new features or to regression test, we shall be able to see how we perform compared to past iterations of the executions. And as well, integration to unit testing and code coverage tools. That's also an important aspect, that a lot of unit testing tools, they play hand in hand with code coverage tools. One of key metrics for the unit testing is the code coverage. So we need to be able to see if unit test that we composed, the unit test suite, covers as much as possible code base of the script that we developed, so that we don't see any code which has been developed but which is not tested. And commonly, it will be a metric of code lines. So we see from the entirety of code lines of this script or the entire development, how many of them has been passed through when the script in a unit test scripts were executed. And sometimes it's path-based. So we look into which functions in larger bits, or which functions or which methods were invoked, and so on. The more common is length of code. The next one is mutation testing. It's less popular technique. It's not very widespread technique in the testing, but it also goes hand in hand with unit testing. So unit tests, they evaluate and they test the code that we developed. For example, our script or our function that we will use in the script. Mutation. The question is, what capability will test the quality of unit tests? So we mentioned code coverage. That's a quite linear metric and quite popular metric. But even when we have a high degree of code coverage by unit tests, it doesn't guarantee that unit tests are of high quality. And this is where mutation testing steps in. So mutation testing idea is that we deliberately inject mutations. So we change the code, and then we look into if the unit tests that we composed will capture and detect that mutant. So literally, we change something in the code, we rerun the unit testing and see if unit tests still succeed or they fail. If all unit tests always succeed, this is a good metric, but that's a quite worrying signal. So we shall be able to reproduce situations or to generate situations where unit tests will start to fail, because this is where we will be able to see if unit tests are of high quality. The constraint of the mutation testing is that those tools which are quite popular in the Java ecosystem, like for example, PIT or PITest, they operate on the bytecode. So what we develop in code editors for Java is a Java source code. Then commonly it will become compiled into the bytecode that gets executed by the Java virtual machine. So those mutation testing tools, they inject mutations into the bytecode of the tested application. But for scripts in SAP Cloud Integration, we don't need to compile them preemptively. So the output of the development, the artifact that we further import into Cloud Integration is the source code of the script. It's not the bytecode, the compiled bytecode of the script. As a result, the usage of existing mutation testing tools, it's not something that we can apply to Groovy immediately and accurately. But we shall not forget about this technique in general. So even though we're testing script with unit testing, we also have to have something that will test a unit test. The other part is performance analysis. We have two sections in here. So one tool set is performance analysis profiling tools. So this is where we can analyze how CPU behaved. So what's the memory consumption, input output, especially if we have some intense interaction with input output subsystems, like with a network or with a file system. For this, we have tools embedded in SAP JVM, and also we have some third-party tools that can be used. And this is to detect any resource leaks or any performance bottlenecks. The other aspect of the performance analysis is benchmarking. There are different flavors of benchmarking. The one that is more relevant to Groovy script development is micro benchmarking. So this is where we run the script under test many times. Commonly, it's a matter of hundreds, if not thousands times with the input. And we look into how the script behaves in this kind of statistically correct runtime. So we would like to produce a stable runtime to where we place the script. It's not one-off execution as is commonly for the profiling. So these two, they play hand in hand as well. So profiling is the one that we analyze resources consumption. Then in benchmarking, we analyze the script execution time when the script runs many times. And for this, we also have tools that can automate this execution and then which can calculate statistical key figures about it. All dynamic analysis tools, they require execution of the script under test at runtime. And this is where we have a significant constraint. We cannot execute this tooling, we cannot apply these tools to the worker node of the Cloud Integration runtime where scripts are executed. So we cannot make performance measurements right on the worker node. When I say we, I mean like customer community. As a result, we have to provide emulation of the runtime. So we have to run the scripts at our local runtime, which is related and which is prone to inaccuracy in reproducing the runtime, because still we have some assumptions, we cannot reproduce it accurately. The other problem is we cannot emulate the entire real-world workload. So worker nodes in Cloud Integration, they don't run a single iFlow commonly. They will run a lot of iFlow instances, and they use a shared resource pool. So in order to be more accurate with the testing our script, not isolated test, but put into real-world conditions, we have to emulate that complementary workload as well, which is in its own quite challenging requirement. So altogether, due to these constraints and the impact of those constraints, any measurements that we do locally they shall be treated as relative, not absolute. So we relatively look into how performance improves or degrades in the script. It's not the accurate measurements that we can take one-to-one and expect that the same value will be received at a work node. So be cautious when trying to apply dynamic analysis tools. And now we come to almost the last slide of the presentation. That's a list of tools, and I highlighted those tools which are more convenient and applicable for Groovy development that I found useful in my personal experience for those techniques, both static and dynamic analysis that we just discussed. So I would like to highlight that IntelliJ IDEA is very powerful for Groovy development. Although those of you who are comfortable with Eclipse and Visual Studio Code, you will find a plethora of extensions and plugins. We have coding assistance where I would like to highlight Codium, which worked really well with Groovy development. Although a lot of developers I know they use GitHub Copilot, that one shined well with Java, but it was outperformed by Codium for Groovy development. And I would like to draw your attention to the StarCoder. That's another one that is evolving. It's quite recent, but it also was trained on a large code base of Groovy scripts. For version control, as I mentioned, a lot revolves around Git-based version control systems. So those can be GitHub, GitLab, or some offerings from hyperscalers. For dependency management, we have Gradle and Maven as modern build tools. We also have Ant from Java. Gradle, I found myself more convenient for my needs, although Maven can do very similar things as well. And then for dynamic tooling, we have static code analysis. SonarCube is a very powerful tool set, and it has plugged in for Groovy code scanning as well. Unit testing, Spock is very native to Groovy development as such, and is very declarative. Although we can leverage pure Java testing frameworks and libraries, I've personally found Spock more convenient for Groovy, which also plays in hand with test coverage. Commonly it's Jacoco, although some tools can use Cobertura, so that Spock, for example, can natively use Jacoco, so that we can see the code coverage right after execution of the unit test suite. For mutation testing, as I mentioned, there are tools for Java and for some other languages, but we're lacking the efficient tool for Groovy at the moment. For software composition analysis, Snyk is something that I would like to draw your attention to. It's the company who produces a lot of tools focused on software security in different aspects, and also they provide tooling that can be used for dependencies management and composition analysis for Java and for Groovy projects. For performance analysis, we have a plethora of profilers in here. And for micro benchmarking, we don't have Groovy specific benchmarking tools, but we can borrow those which are common in Java community. And here JMH, Java Micro Benchmark Harness, is probably one of the most popular tools when it comes to micro benchmarking of Java applications and the Java code base. With this, I would like to really thank you for your time. Thank you for your attention. And we will be very happy if information that which was presented in this session, if it will be helpful to you and if it will help you as an integration developer improve your workflow and also to improve the quality of scripts that you develop. Thank you.
Thank you very much, Vadim. There's a couple of questions in the chat. I think you addressed one regarding the dynamic code analysis. But there's another one that says, what guidance would you provide for designing unit tests prior to commencing the development of an integration flow? Yes, just that. If you can share something regarding that.
Yes, so very commonly, it's not the only one, but very common requirement for Groovy scripts is we have to manipulate with headers of the message, with the body of the message, and exchange properties. So when we design a unit test, firstly, I would promote the idea of designing tests upfront. So when we have certain requirements that we would like to implement in the script, we already can start thinking about which unit tests will cover those requirements. So for example, it's kind of test-driven development approach. So we can design a set of unit tests, a unit test suite, even before we started to implement the Groovy script for cloud integration. For example, we can compose inputs that are expected. We have to cater both common cases and corner cases, edge cases as well. So we would like to test our script, how it will behave when we have some edge case input, for example, some message header or some payload which arrives. And then we can produce the output that is expected. So unit tests will be centered around particular, for example, mapping requirements or encryption requirements. If it's mapping requirement, I would suggest that we can test it for the whole document that is produced. For example, we have some JSON documents that we convert into something else. Then we can test the entire output document in the unit test. And for those unit tests, the important aspect will be also the quality of input and expected output, and the coverage of input and output for the script. So although there are quite a few components that get feed into the script, so these are components of the message itself, exchange property, and the context. And the context is probably one of the most complex to emulate. For others, we have higher degree of emulation. It's important to firstly sit down and think about what are possible inputs that can arrive to the script, and also what are inputs that potentially can arrive, but which are abnormal cases for the script, because then we can test, for example, error handling or corner case situations handling, and also exception handling within the script. So this all has to be fed into the input of the script.
Excellent. That is clear to me. There's an additional question, and I imagine it's related to the many tools or techniques that you discussed during the presentation. And the question is, what is the effort in getting all of this to run? So all of the different tools, and to make them part of your workflow, what sort of effort are we talking about there?
It's a very good question, and it kind of relates to developer productivity as well. So for quite a lot of these tools, we have extensions and plugins that can be added into your into IDE or your code editor of choice. So these tools can literally provide additional views within your code editor or IDE, where under the hood the tool will run and will present you as a developer the output of that tool. Plus, a lot of these tools, they have CLI command line interface applications, which make it possible for those tools to get embedded into the pipeline. So those tools can be invoked by the CI/CD pipeline. For example, we committed a change to the script to a Git repository, and then it will trigger execution of the tests. And a lot of these tools, that they can be triggered as distinct actions, distinct steps within the pipeline execution. Plus, some of these tools, they do produce nice output, commonly in HTML output, that we can further pick up and analyze. So here we approach it from two things. One thing is we have extensions and plugins that we add into the IDE, and we literally extend the developer workflow with those tools, so we can quite early make the executions of those tools. And secondly, we can embed it into the official testing pipeline for the development based on the CI/CD platform of the choice of the company. So it can be something that can be embedded into hyperscaler offerings, or if the company runs tools on premises or elsewhere in the cloud, they can also embed it. For example, GitHub do offer these capabilities. Azure DevOps services, they all offer the capabilities to create a custom step as a part of the pipeline execution.
Okay, thank you very much for answering this. That's it. We don't have any additional questions. So thank you very much, everything, for sharing your knowledge and expertise in this session. And I also want to thank the viewer for joining the live event, or for watching the recording of this a bit later. And a reminder, there is plenty for everyone to learn during the Toolfest. So make sure to check out all the sessions that are part of the event. Thank you very much.
Thank you for having me here, Antonio.
Thank you.
To everybody, goodbye.
See ya.